Quantum Hardware with Diana. Introduction.
Hi, my name is Diana. I'm a high school junior in the Qubit by Qubit Introduction to Quantum Computing course. Today, I'm going to be talking to you about quantum hardware. Quantum hardware, what is it? Well, before we go into answering that question, we need to first define what a quantum computer is. Now, a quantum computer is a type of computer that uses the principles of quantum mechanics, I know, pretty fancy, to be able to perform calculations. Unlike classical computers that process information through bits of zeros and ones, quantum computers process information through the use of quantum bits, also known as qubits, which are a superposition of zeros and ones. And when we talk about in the state of superposition, all we're really saying is that the bits are in a state of both of 0 and 1. Now, the best analogy I can really provide is think about it kind of like when you flip a coin. When you flip a coin, sometimes it does that little spinny thing, and you can't really say if it's heads or tails. It's sort of in the state of it being both heads and tails. That's kind of the idea of superposition. You can't really say it's one or the other. Quantum computers have the potential to solve many problems and possibly create even new ones, especially in the field of cybersecurity. They're still in the early stages of development, so they have a lot of potential. So, how do you build a quantum computer? Maybe you want to take over the world with one. But, that's probably not going to happen. You need to amass some political power and all of that. So, but hey, you can always dream. Anyways, in order to be able to make a quantum computer, you need hardware, which, if you don't know what hardware is just simply the physical components of a computer. You need hardware that is equipped to run quantum algorithms. Now, since quantum computers are still in their early stage of development, there are many types of quantum computers that are being currently developed. Now, in today's video, we will go over the many types of quantum computers and their hardware. Now, which ones are we going to go over? We're going to be going over the superconducting quantum computers, ion trap quantum computers, photonic quantum computers, topological quantum computers, and other fun ones. So, without further ado, let's get into it.
Types of quantum computers.
Starting off with superconducting quantum computers, the most common type of quantum computer being currently developed. Superconducting quantum computers use superconducting circuits to manipulate qubits. Now, you may be asking, what does superconducting mean? Well, superconducting simply means that a material has a property to be able to run electric current with little to no resistance. Now, if you ask me, I think that's a pretty cool property to have. Now, these computers are usually made from metal and are kept under and I mean very cool temperatures. How cool are we talking? Well, we are talking almost near absolute zero. Yeah, that's how cool we're talking. So, yeah, it's pretty cool. Now, as for some pros of these computers, they have high qubit coherence, which basically means that the qubits are able to be in their quantum state for longer periods of time. And they're also very scalable. So, if we want to make more of these superconducting quantum computers, we're able to do that with fairly good ease. Um, so, yeah, that's kind of the pros of those superconducting quantum computers. Now, as for the cons, because of environmental noise, qubits are susceptible to errors. And like I mentioned, these qubits need to be kept under very cold conditions. So, because they need to be kept under very cold conditions, you can imagine that the equipment is going to be quite expensive. That's why a lot of companies like Google, IBM, Honeywell have are able to develop these superconducting quantum computers. So, yeah, that's kind of part of the whole deal with superconducting quantum computers. And by the way, if IBM, you're somehow watching this video, please hook me up with an internship or a job in the future. I love you guys so much. So, yeah. All right. Enough of my self promo. We're going to move on to photo. Um, Sorry, not photo. Ion trapped quantum computers.
Trapped ion quantum computers.
All right. Up next is ion trap quantum computers. We will get to photonic quantum computers, but that will be after we discuss ion trap quantum computers. Now, these ion trap quantum computers use ions, which are atoms that have a negative electric charge due to losing or gaining an electron, trapped in an electromagnetic field as qubits. Now, as for how they look like, well, I'll insert a picture here as for how they look like. Pretty interesting, right? Now, in order for these computers to work, they need to be 100% isolated from the environment to prevent noise. Now, when we're talking about noise, we're specifically referring to quite literally any distractions, I guess, in the environment or anything that could really disturb the qubits. So, because they need to be very well isolated, if they're not, then the quantum state of the qubits can be destroyed. And that causes a lot of issues. So that's kind of one of those cons to the ion trap quantum computers. So as you can imagine, this is very much a setback for these type of computers. Now, all these computers can be a bit finicky and delicate. They do a pretty good job of having high quality qubits with low error rates and long coherence times, which, if you remember, is just a qubit's ability to be able to remain in its quantum state for a long time. Okay, now on to the photonic quantum computers, which I mentioned previously. So if you guessed that these quantum computers use photons, then you would be correct. It's quite literally in the name, so it's not hard to guess. But now the question is, why do we use photons? Well, photons are actually pretty good at carrying information from one location to another. Unlike superconducting computers, you don't need to keep them at a near zero temperature. You can actually keep them at room temperature, and by them I mean the qubits. So that's a big pro. So each photon is used to represent a qubit based on the properties of each photon. And now, because the computers are good with carrying information, well, you guessed it, they're great for quantum communication and even cryptography. Cryptography. You know what? I should really make a video on that. Um, I'm in my cybersecurity class, and we're going over cryptography, and I absolutely love it. So definitely will make a future video on that. So be on the lookout. All right, now moving on to the last one we're going to be majorly talking about. We'll cover two other fun ones, but topological quantum computers. Now, let me tell you, quantum topological computers just honestly just have me confused. They are a bit whack. Now, honestly, I would say that topological quantum computers are just more of an idea and kind of just a concept for as of right now. But maybe, hey, once I enter my undergraduate and maybe even graduate studies, I'll be able to get back to you guys on that, because on this specific type of quantum computer, because it's very confusing. So just from what I was able to gather from my research, topological quantum computers use these fancy particles called anyons. Possibly be pronouncing that wrong, which is a quasi particle or quasi particle, however you want to pronounce it. So, from my understanding, quasi particles are kind of like particles, but they're like not like particles. Yeah, they're very very confusing, and I feel like this could possibly be a future video of me like digging deeper into this. But for now, we'll just say that topological computers are whack, and there's probably still a lot more research that needs to go into it. So yeah, they're definitely under development. So as for the two fun ones, let's get into those.
Fun quantum computers.
Okay, so as for some of the fun ones being developed, there are diamond-based and cold atom quantum computers. So sorry for my pronunciation, but diamond-based quantum computers basically shine a fluorescent green light in the center of a diamond, and they are able to like basically detect and make photons. So they're kind of related to the photonic quantum computers we previously talked about, because again, photons are really good at being able to send messages and just in general, just very good for communication. So yeah, that's why they're being used, which is pretty interesting. And similarly to superconducting quantum computers, cold atom quantum computers use atoms that are a teensy bit above the absolute zero temperature. So yeah, again, quite literally in the name, cold atom computers, quantum computers just use very cold atoms, I guess. But Cold Quanta is one of the leading, I guess, organizations, companies working on the development of these quantum computers. So it's pretty wild, in my opinion. But yeah, I guess those are for some of your fun quantum computers out there. And I feel like it's really interesting to see some of these really creative ideas for the development of quantum computers.
Conclusion.
Woo! That was a lot. Okay, so we just covered a lot of the types of quantum computers and the hardware associated with them. It's honestly cool to see all of these types of quantum computers being developed during the baby years of quantum computing. I mean, who knows where our quantum computers will of the future will look like. Maybe this video inspired you to study quantum computers in the future. I know that when I first started learning about quantum computers, I definitely just fell absolutely in love with them. And I know that it is something that I definitely want to study in my undergraduate and possibly graduate studies. So, you know, be on the lookout for my future endeavors in doing research with quantum computers in the future. And who knows, maybe I'll be able to look at this video and be like, I know so much more about quantum computers than I did when I was in high school. So that's the ultimate goal. Anyways, I hope you learned something new today. Be on the lookout for more quantum videos in the future. Make sure to like and subscribe. I love you all, and remember to stay nerdy.
Thanks for watching. Until next time.